Hello everyone.
Hello, sir.
Hi. So how's the sessions are going on? How MLP is going on? I'll just give me a few seconds so that I can open all the tabs. Let's wait for a few more minutes so that others can also join, and after that we will start. So as you guys have got the notice that first we will show the all the coding part collab, which you can refer later. Uh, have you gone through any coding part which you saw that it was missing in videos? Hello, am I audible?
Yes, you are audible. Can you rephrase your question?
Yeah, I was saying that as you would have got the mail, that, sometimes the coding is not visible, some coding part is not visible in the slides. So it was told that we will show that those codes and during the first 5 minutes of the live session. So
So for the MLT, there is like complete class which is missing. But for MLP for this week, there was very few codes which were hidden or like that.
okay. So in the every session, since it is the MLP session, so I'll show all the codes once and for 5 minutes. Then after that, we will start the session. So in from now onwards, in every session, we will do these things. In MLT side, like MLT side also, they will show all the codes first. I think you guys would have got the mail, no?
Yes, sir.
Yeah. So let me open all the codes. I'm just opening the codes. Hmm. So is my screen visible?
Not yet, sir.
No, no.
Okay, I'll send.
Yes, it is visible now.
Yeah, let. Okay, let's also this one. Is it enough pace? By this pace, can I go move forward? Hello.
Yes, it should be okay.
Yes, sir. Fine. It's fine.
I think you are going too fast actually. Like it will be very difficult for us to like pause in between.
Yeah, please stop me whenever you feel no.
Yeah.
Stop me because this is the first time we also don't have idea like yeah. Since no one is saying anything, so I'm also feeling a bit awkward. Like okay, do you want I should pause at any particular place?
Yeah, but I'll tell you.
Okay. So I think more or less this one is covered. So can I move into the
Yes, sir, it's clear now.
Can you scroll down once?
older one or this one?
No, no, down, down. Regarding that coefficient part, that polynomial coefficient,
Okay, okay.
there was a graph that you had got.
The thing the Trivium is asking is in another collab, that is like linear regression part, not in the California.
Okay, 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 okay.
No, I think it was in this only. It was at the bottom.
Are you talking about this one?
Oh, no, no, sir. Even below. I think it is in a different one.
This one.
No, sir, no, sir.
So it was in the second tab in your Chrome, that is linear regression collab.
Okay, okay, this one.
Yeah.
Yes, sir, this one, this one. So can you please explain what is happening here exactly?
So they are doing the whisker plot, and they mentioned like they mark this whisker as uh, in black color and median they have represented by black color and the caps. Okay, so I have to also go through that. I think they have mentioned they have. Are you aware of this box plot or something like that? Are you saying?
I'm aware of it, but I'm not. Is this a quartile, that same box, right?
Yes,
Window?
yes, yes.
Oh, okay, okay.
Yeah, the same blocks.
I never come across a plot where we are representing weights in such a fashion. That's why I'm intrigued.
It is not a weight actually. I haven't gone through the codes, so I need to go through that. But normally, what we do is like this box plus we use to see whether there are any outliers or not. So here we can see that in the occupant longitude we have some outliers. So it is a good style to check about the outliers.
Okay, okay.
So that's why we do the kind of plots.
And
Uh,
the coefficient is represented by bold black, right?
yeah,
Okay, okay.
yeah, yeah.
Okay,
And
so you're just covering the outliers, showing
yes,
how.
yes, yes, yes. Is this done or okay? So sir has just mentioned about these things. Okay, so more or less we are done. Okay. Should we proceed further on? discussing activity question.
Sir, I had a doubt in this, that linear regression.
This one.
Sir, in the beginning, we split the data first into training and testing set,
Yeah.
and then the training set was further divided.
Yes.
Okay, but then we didn't use that part of that that development or something. It was called something like the dev
Where?
in the beginning. The very first step, you can say, second step actually.
Somewhere this.
Yes,
Somewhere.
next to this. Yes. That splitting of data. So first we have split it into training and testing, and then again that dev features and dev labels. We haven't used it anywhere in this slide. In this collab. So why was this done?
See, actually, I have also don't that much idea, like, because I haven't gone through thoroughly through this collab. But yeah, usually if he would have done this, then I need to see that, because what I heard, we will discuss these things on the in the open sessions. So it's okay. I'll just check. I will also have to look at these things.
Okay. No problem.
Yeah.
I just wanted to know whether it is required for linear regression or it is just done because we do it every time in practice.
Yeah. See, I don't know in what context.
Sir,
they
may
have
I
done.
answer to this question?
Yeah. Sure.
So yeah, so sir, in the test feature, in the first test, train test split, we have divided into train and testing. We are not going to touch the test features and test labels until the end. And now we have divided the train into train and development split. So we are going to use this for cross validation and testing our metrics, whether we are performing, whether that training is performing with what metrics. So we are going to first calculate the metrics on development sets. When we are good with the numbers which we are getting, then finally we test on the test features and test labels. So this was the purpose.
Yeah.
But in this collab, I think that dev, I don't see anywhere it is getting past that development set and development.
No, Harshad, if you see this common trans, which Rohit is telling, in common trans
No,
itself.
I understood, sir. But I just want to know whether it was required here or it is just done because it is common practice.
Oh, it's
Yes.
a common practice, and every time it's used in the same way.
Yeah. So in general, what we do is we just divide our data set into three parts it is like a training, evaluation, and test split. So what we do is we train our model and then we check it on evaluation split. Finally, we touch it. At the end, we check the test part. Okay. So it is like that. In general practice, we do this. So in particularly this collab, what is done, I need to go through that. Okay. So as you are saying, what you are saying is that they haven't used this depth part.
Yes. At
Okay.
least in this collab. That's what I meant.
Yeah. Maybe in this collab, they would not have used it. It may happen, but I need to check that. Okay.
Actually, we are using this shuffle CV now. Shuffle CV will take this.
It does it automatically.
Internally,
right?
it will do.
Yes.
Maybe dev feature has not used exclusively in the program. Need to check.
And sir, what is the default thing for this train test split? Because there is no, it's not. Test size is not mentioned here, no.
Yeah. Sorry.
I'm saying
25%, default 25%.
Achha, all right, default 25%. Okay. Thank you.
So yeah, let's start with this.
But shuffle split CV, that there you give a
we have to
folds, right? You give the n splits equal to 10.
Yeah.
So n splits equal to 10 means it will create that 10 splits, and here you are mentioning that test size equal to 0.2. So that means internally you will again do this test sizing there. So essentially what the other person is telling, like that development, that validation stuff, that has never been used practically in this code.
Yes.
Yeah, it may happen I got your point. What you are saying is he has intentionally divided here train test and all those things, and still again they have divided it, and they didn't use this anywhere in this collab.
Correct.
Is this
But
your
after say for example cross validation, if you want to see like how that guy is like, no, like even that is not good, because after cross validation you get the test score, and that is based on that test size equal to 0.2 in the shuffle split CV.
Yes.
Right.
Yeah. So are you asking a question or it's a statement? I would say.
No, like I'm still like in that opinion that that particular data has not been used in this collab.
Okay.
Yeah.
Yeah, then yeah, I'll check that whether it is done like it's a redundant thing or something like that. I'll check that. Okay. So yeah, basically this one is enough, because what we are doing, like we are keeping 20% data for like for testing purpose, and we splitted our data into 10 parts for cross validation. Every time we are training our model on 9 parts and just testing it on the 10th part, something like that we are using continuously. And at the
Correct.
end we
No,
are collecting. Yeah.
yeah. And like one question, like in that cross validate, right? Like
Yeah.
we are not specifying any kind of a how many number of times like it has to run, right?
It will run, it is fixed, no, like every time it will run, like see, let me use some diagram purpose which will show you.
I think wouldn't that depend on the number of splits? So, for example, if there are
Yeah.
10 splits, so for example, I mean, if one is kept for validation and the rest is for testing, so for each iteration, it would run 10 times.
Yeah, exactly. That is what I
No,
want to visualize.
that is perfect. Like it is not going to eat each iteration. It will not run for 10 times. It will like whatever the data, it will split into 10 parts. Okay, and then it will use 9 parts for testing, like training, and 1 part for validation. That's what that in split equal to 10 means, right? But my
No.
point is, yeah, good.
No. This is not the case with shuffle split. In shuffle split, there will what it does is it first shuffles the entire data, then takes 20% for test and 80% for training, and it does 10 times. The number of split is it. This process is done 10 times. So this is what shuffle splits does. In k-fold, the thing you are telling is in k-fold cross validation.
So whether my screen is visible or something, whether
Only Chrome is visible, not the.
okay, I think so. Still, okay, let me try to, because I have opened it and I need to share that part also. Yeah, so whether this line is visible or something, like, hello, is it visible, something like, so I am drawing something?
No, sir.
No.
No.
Still collab.
Okay. So okay, I'll discuss it manually then, because what happens here is we divided our data into, let's say, like 5 parts. Okay, so what every time is iterating is like it kept it as what I'm able to guess. Your question is, you are saying that how many times it will iterate, something like that. Are you asking, Raju? No?
Yes.
Yeah. So what will happen here? What will happen is, like, suppose you kept 5 parts. Okay, you divided your data into 5 parts. So in the first case, what it will do, like it will keep the part, just name a number as like 1 2 3 4 5. Okay, set 1, set 2, set 3, set 4, set 5. So just in the first run, suppose you kept your set 5 as separate, you trained your model on on the all the 4 set, like set 1 plus set 2 plus set 3 plus set 4 will be your training data, and set 5 will be your test data. Okay, in that case, and you just trained your model on these 4 sets, and on the 5th set you check your score using those evaluation matrices. So like that, it will iterate through all the parts. Like in your model will get trained on all the part of data. Okay.
Okay, now the question is, like, if you are saying it is like that, okay,
Yeah.
it will train on first four parts, and then one part it will keep for testing.
Evaluation you can say. Yeah.
Then
Okay.
what is this test size 0.2?
So this part we have kept separately. Okay. Like we kept this part as a separate folder, something like that. Like we don't want to touch that data, something like that we are doing. Are you getting?
So like okay, so first it will split that data, then it will make this in this case like 10 partitions of that data. Say
Yeah.
for example you have 100 data points, okay,
Yeah.
100 data points. First you will create 80 data points for training and 20 data points for testing. Now this 80 data points will be divided into 10 splits. That means 8 8 8 each, right? That's what you are saying.
Yeah, something like that I'm feeling.
Oh, I think we're getting confused between k-fold and shuffle split here.
Right.
Yeah.
Yeah. Can someone like
Someone can pin.
See, in shuffle split, when you are telling 10, means you are dividing your data into 10 parts first. Okay. So entire data will means if every set will take and it will make a 10 different sets. Suppose you have the sample of 5. Okay, 5 records are there. Then it will combine out all 5 and it will make 10 different combination. And from that combination of a single record, then it will take a 0.2 and aside as a test example.
Exactly.
I don't know.
Just
No.
correct me.
Yeah, that is what it is. Yeah, just.
So, I mean, I just want to say what my understanding is. Correct me if I'm wrong. So what shuffle split does is it takes the entire data, keeps aside 20% for testing and uses the 80% for training. This is one iteration. And when you say n splits equal to 10, it does the same process 10 times. So every single time it uses the entire data and sets aside the 20% of the data for testing. Is that correct?
So you are saying basically it is doing something. Just repeat your answer, I think.
Every time it shuffles the data and keeps aside 20%. And when you say n splits equal to 10, it means it does this for 10 times.
Yeah, that is what it is doing.
Yeah, because we know the one which you told, the 1, 2, 3, 4, 5.
Yeah.
That is the k-fold, right?
Yeah, k-fold.
That
is for
different.
k-fold. Here you, as you are saying, that is what it is happening.
No, that is that the k-fold is, I think, different from this.
Yeah, k-fold is different. I think actually we are just getting mixed with these things. See, I'll just brief you. In the k-fold, what we are doing, like we kept the 5 parts. Okay, so we are just taking that 4 part and testing on the 5th part. Like that, we are iterating, and we are completing all the 5 parts. We are training. I mean, our model will get trained on 5 times, something like that. Okay, and in the shuffle split, as you told, what we are doing is like we are keeping 20% data as the name suggests here only. Like it is a shuffling. It will shuffle the data, and 10 times it will shuffle the data and test your model on 20% data, something like that.
Exactly, yes. 10 times it will shuffle the data, and every single time it will keep aside the 20% of the data for testing.
Yeah, that is what. Yeah, but yeah, I think we just got confused.
Okay.
Like, yeah, by lenses or something like that. Okay, so I don't know why my screen. So this one, is it visible? This time this course. Hello.
Yes, sir, it is visible. NPTEL, right?
Yeah. Actually, I had opened some whiteboards, which is not helping me to draw anything. Okay, so in the first question, It is saying which of the following API will generate a new feature matrix consisting of all polynomial combination of the features with degree less than or equal to the specified degree. So we all know that in a scale learner library contains these polynomial features. So I think, yeah, rest all others are wrong answer here. So, and it directly comes from the definition, like it is written clearly, directly the same statement in the sklearn also. So is there, yeah, no one will ask anything. Okay. So yeah, in this question, what it is doing, like in the first sentence, it is importing linear regression library. And in the second line, it has imported the pipeline. And then in the pipeline, first it is doing the polynomial transform of degree 3, and then applying linear regression on it. So yeah, the third option seems correct. It will apply the polynomial transform of degree 3 on feature matrix X, and then we'll learn the linear regression model. Yeah, so I think all of you knows the answers clearly. So at any point, if you feel some discussion is needed, so you can stop me and we'll start discussion. Okay. Hello.
Yes, sir. Yes, sir.
Yeah, I think yeah, I feel like, yeah, the state got disconnect something. Okay, so in the third question, it is mentioned like since interaction only is true, so obviously the terms like x1 square, x2 square will be vanished. So the third answer seems to be correct, like 1x1 x2 and x1 x2. So yeah, all these three questions, yeah, we are done.
If interaction was false, then the last one, right?
Yeah, last one.
Okay.
So I think it looks some answer we did.
So you marked the last one wrongly.
Okay. Sorry.
Third option.
This one, no? Okay.
The marking
So,
is wrong.
yeah. Okay. So here they have kept it at 4%. Okay. So yeah, in the activity question 4.2, which of the following are correct ways to perform regression with regression rate of 0.2? So yeah, as we know, like we can perform regression on using first on the normal equation and the second on the algebraic regression. So yeah, for normal equation, this code seems to be correct. Like we imported this linear res part from linear model, and then we applied the res. By keeping here, we kept the alpha equal to 0.2. Second statement, as we see that it seems this is not the format of that regression in a scalar library. And yes, and in the third and fourth option here, since they have used is L1, so since L1 is used for lasso regression, so obviously fourth one will be correct. Are you guys with me?
Yes, sir. Yes, sir.
Okay. So which penalty method is used to perform both lasso and regression?
Elastic.
Yeah, in polynomial. It's a combination of both one. So can someone recall like what was the shape of that L1, L2 and elastic net? That diagram. Yeah.
It's combination of L2 and L1, right?
Yeah. So that shape I was saying, that circle thing, that parallelogram, and then that square.
So, but I've just gone through the lectures once. So this elastic net concept, can you please explain once? Like, I don't understand how L1 and L2 both can occur at the same time.
So what is he saying is no. Let me just again rest. That whiteboard is I haven't allowed it to show. Okay, I'll just pause sharing. Again, new share. Okay, maybe it's good. This time, are we able to see all the parts, all the things? Yeah, hello.
Yes, sir. Yes, sir.
Yeah. So is this visible this time, this whiteboard?
Yep.
Yeah. So what is it doing now? That in the elastic net is we are taking something like combination of like suppose in the one question it is mentioned like 0.3 L1 plus 0.7 L2. Okay, so we give the weightage something like that. So we are just providing a combination of L1 and L2, something like that.
Okay.
Yeah. That is
Okay.
what.
0.3 L1. So it's going to be the regularization is going to be 0.3 absolute weight of W1 plus 0.7 not W
Yeah.
equals W.
Whatever your L1 formula is in there, no, just you are providing one extra term of 0.5, 0.3 on that.
Okay. So this regularization, this 0.3 L1 plus 0.7 L2, I have to do for every iteration of the gradient descent calculation, correct?
Yeah.
Okay. I thought that 30% of the iteration will do for L1, 70% for L2. Okay. Got it.
Okay, so which of the following keyword parameter is used to set regularization type? So to just answer this one.
Alpha, right?
Yeah.
No, penalty.
Penalty, no?
Alpha is the value.
Sorry, penalty. Sorry, yeah, penalty.
And alpha is the regulation rate actually.
Yeah.
So in the first time, like I was also reading, no, I was just I thought that alpha, this part alpha. Then again, I thought that it is a regulation type, not regulation rate. So that's why I just asked. Okay. So consider the following question. Yeah, in this question is writing like SGD regressor. They have kept a penalty as elastic net L1 ratio equals 0.3. So what is the L2 ratio? Okay.
0.7.
Yeah.
1 minus 0.3.
Yeah. Like that only. So all these things are correct. Okay. So now let's move on to the activity question 4.3. So this time I think in this chapter, in this week, the activity questions are a bit less. Which of the following statements is correct about the hyperparameter? Okay. So I would ask about the like what do you understand by hyperparameter? I think sir would have covered it, but yeah.
So those are those parameters that are specified in a variable in a parameter called as param grade. And these parameters are basically searched upon in grid search. So basically what they do is they try all combinations of the parameters of the hyperparameters, and whichever one is given the least loss, the validation loss, they pick that, and then they give us that. So
yes, you showed the larger picture. Okay.
What exactly are hyperparameters? I mean, are they something? I mean, anything apart from weight vector is considered to be a hyperparameter, or?
Hyperparameters are those variables which the person who's like running the model is inputting, right? Like it is those which are used to control the model.
Yeah, exactly. That is
it is inputted by the who is designing the model.
Yeah. But still I would okay, here only I okay. So in the linear regression part, can you name some parameters and hyperparameters?
Learning rate will be a hyperparameter. Number of epochs will be a hyperparameter.
Even degree is also an hyperparameter because we need to pass which degree we need to pass. Degree is also a hyperparameter.
Okay.
The weights are the parameters.
Yes.
Yeah. So weights are the parameters. Okay. So from here, what is the difference you are getting in parameters and hyperparameters? Since who has told the difference? Some other person. Can you differentiate that? What is the difference in that weight and learning rate? Like
learning rate we can decide. Weights the model decides.
Yeah, that's true. Okay. So next question. Okay, as you said, like that is something hyperparameter is something that we set. Okay, something like that, no?
Right.
Yeah. So in the questions, I think in the few of the questions we have done that, like we have selected few number of features, like suppose there are n features is given in the question data set. We selected like n-2 and -3 features for our model. Have you done something like that in the previous lectures, or have you not done?
No, I don't think we've done feature selection till now. I'm not sure. Like I can't recollect.
Yeah. So suppose there are some basic examples of linear regression. Are you aware of that?
So can you repeat?
This is I'll go to the question after this one. Like there are some basic assumption of linear regression. So
we have not heard like this.
okay, so there are 4 basic assumptions of linear regression, and only we train our model based on that. So what it says is linearity, normality, then independence of observations, and homoscedasticity. Okay, 4 basic assumptions are there in this linear regression. Okay, so linearity, what it says, like a line of best fit will be a straight line, something like that. Okay, just remove that concept, this part, polynomial regression. Just keep it aside. Just I'm talking about that linear regression. Okay, so then second assumption, which is normality, which says that like our data follows normal distribution. Okay, and then the third is like independence of observation, like no hidden relation among the variables. Okay, and the fourth one is homoscedasticity, which says like the size of error doesn't change significantly across the values of independent variable. Okay, are you guys with me or something like that?
What is the second one? The normality? How?
Like it says like the data follows the normal distribution, all the data, like all the columns is there and all the features, so they follows normal distribution. These if these assumptions are correct, then only our linear regression model will perform good. So that is what I am saying.
Which means linear regression works only on normally distributed data.
Yeah,
Or
that is also an assumption. Yeah, so total 4 assumptions are there. So here we don't have that assumption, no. Okay, let me.
But how do we check this 4 assumptions before, even if we go with applying a linear regression model? So even if before we do a trend test split, even before we define an optimization, so is there any way to do it? How do we do it?
Yeah, you have to check those things, because see, in the then only you will use that thing, that linear regression model. Okay, so in the next in the solution success session, obviously I'll just go through some data and I'll go through each and every steps, like whatever you have learned till now, and we will apply on some data sets, like how, like step by we think, like some based on some industry problems, something like that. Okay,
Yeah. So just correct me if I'm wrong. So in the MLT techniques course also, I'm not sure whether this was mentioned. These are assumptions we should check before, even if we go ahead and implement the algorithms.
Linear
Right.
Yeah, MLT actually properly, that is what MLT does is like MLT is proper just coding part, something like that. So we should cover it in MLP, but I think
Yeah, my worry is that even if I go ahead and simply implement it without even knowing assumptions about each and every type of analysis, then we might be doing something grossly wrong. So,
yeah, and intentionally or non-intentionally, you did that, no? Here in that term, I think since it is not covered in the lecture, so that's a different thing. But see.
Yes, if you can cover maybe later, because I think this is quite useful and important for us to know, like a prerequisite before even if we start applying algorithms.
Yeah, here also you are seeing that standard scalar they have used, like why we are plotting those graphs. Many graphs we plotted, no?
Right.
Yeah. So what is the use of those graphs? So it is just simple pair plot is there. Many things are there, no? Pair plots were there.
Standard scalar, when we see this, if you describe any data, it will show you mean, max, and if you will find that number of the amount, you can say the decimal part is more, or not decimal. The numbers are very much far from each other. That time we are doing the standard scalar so that all will come in the same scale. From there we can get.
So exactly that is what I'm saying. So why we did that? What was if we were able to apply the linear regression model directly, then why we did that?
So that all data will come in the same scale, and when you plot it or when you make the model, it should follow the same scale. Otherwise, it is going to be learned, but the loss will be sometime high, sometime will loss. That's why we are doing. But it is called normalization.
See, normalization. See, standard scalar. What standard scalar does? Are you aware of that?
Yeah, standard scalar. We have then we have one. The common is that we are doing this the minus mean divided by our variance. Okay, that is one.
Basically centers the data. Yeah.
Yeah, we are centering the data. Yeah, simple centering.
Yeah. So what we are doing, like we are setting mean as 0 and variance as 1.
Right.
That is what standard scalar is doing. Okay. So two things we have here, like we are using standard scalar, or other we can also use that normalization. Okay. Based on that, what we are doing, like we are just shaping our data, just as it is saying norm. And as we like if we are setting the mean equal to 0 and standard variance equal to 1, that means that data is normally distributed. Are you with me?
Yes,
Okay. So obviously by doing that, without being aware, you did that only, this one only, like you just normalize your data in that feature scaling. You scale your data, no? Huh? So yeah, that is what you did. Okay.
Yeah, standard scalar.
Yeah. So one more thing we do here, like we do that as I told you, the independence of observation. Okay. So if you have two features, let's say one feature, if you have two features, if that is correlated, no, I think you are aware of the term correlation.
Yeah, correlation.
Yeah.
We know.
Yeah. So if two features is correlated, no, then it is our job to remove that correlated part, like one of them, because if you will train without removing that correlated features, our model won't be correct. Or so this one is also needed. So we remove that, and I'll tell you in the that's for sure that in the next solution session I'll cover all those parts. Whatever I'm saying, no, all these things I will cover. Because
yeah, I think you are right, because sir showed one heat map where we plotted all the correlation in between the features, so that kind of help us. So probably the intuition, I mean, he showed all the technique, but the way that you categorically mentioned this 4-5 points, I think that was what I mean, at least I couldn't play. So now that you told me, now I could say that yes, he did cover, but not explicitly in the form in which you mentioned now.
Yes.
Yeah. So okay, so in the next class, as I told you, I'll train. We will train the model, and we'll go step by step, like how we'll think, like some related to some business problems, something like that. Okay, by step, we'll think and we'll proceed, something like that. Okay, so I was just talking about that this correlation part. Okay, so due to the correlation, we remove some variables, some some features. Let's say in some cases, just say weight weight is given and volume is given. Okay, so these two things are just, let's say that these two things are correlated. Okay, it is so what you are doing is there are many features given. Okay, weight is given, volume is given. Okay, so what you have to do is, like, you have to remove one features. Okay, you remove that features, weight is you kept and the volume you remove, or something like that, vice versa you can do. So these features also we decide. Okay, like what features to keep and what features not to keep in our model. So I was saying about this so since we are selecting features also, okay, like number of features, so is this, will it be a hyperparameter or parameter?
It will be hyperparameter.
Hyperparameter.
Yeah, so actually the thing is, it is not hyperparameter. Yeah, as logically you are saying, I'll also agree, but the thing is, like, we take it as a post processing technique or iterative tuning process. We take this part as something like that, like it's a pre-processing part, so it is not helping you to optimize your model, something like that. I'm also saying because the thing is, this part we did at the first only. Just search this answer, I will also say. And if you are able to just frame this one, this exact answer, since it's not an hyperparameter, that for one thing is for sure, and it's just a parameter. Features, it comes under the feature section only. So learning rate, all these things. But since still like it's our input, like we are giving that, like what features to keep, what features not to keep. But yeah,
But say for example, when we do a feature selection, right? Say for example, a variance threshold. Okay, that time we give a threshold variance. Say for example, it is 0.2 or 0.3 something we give, right? So anything, any variance like greater than that, it will be kept. Otherwise, it will be removed from the feature. So the value that you are providing, that is a hyperparameter, right?
Yeah, that value is which one? That feature, that portion, no? Yeah.
Feature selection, feature selection.
So
but
we are
what-
talking about the threshold variance, right?
Right.
Yeah.
And that is the hyperparameter. I think sir also mentioned it.
Yeah, that is hyperparameter. I'm not talking about that, but I'm just talking about like to do this. What here we are saying, no, to select the features here, like that feature selection part. I am not saying that you are removing that selection of features. Yeah, I'm saying about that only. So what we are doing is like we are selecting. We are seeing some number of features. What we are selecting, no, that is not a hyperparameter. That is parameter. Number of features.
But polynomial transfer, polynomial feature selection, their degree equal to, say for example, whatever you pass, right? That that is a hyperparameter, right?
Yeah.
So that is again like kind of a form of feature selection, right?
I also agree with you. Yeah, that's why I discussed this part, hyperparameter, because like there are, I also just searched through many arguments. Like when I was saying that, like it's a some it is saying like it's just a processing technique or iterative tuning process, something like that. So that's why it's not an hyperparameter. It's just parameter. But yeah, some
For
concrete.
the sequential selection of the parameter or RFE, that recursive feature elimination, because there also we are giving that how many features we want to select. So that also
correct.
Hyperparameter, or we have to consider as a parameter.
Where?
That
See,
sequential feature selection, or you can say recursive feature selection, where we are giving this n feature underscore to underscore select, that how many feature you need to select backward forward.
Yeah, that you can say the hyperparameter.
These are all hyperparameter.
Yeah, whatever you are thinking, no, every time it will whatever definition we talked, every time I felt like yeah, it is working, but here I was also not sure like why it's not working.
Okay.
So that is that's why I told you.
I think in feature selection we are using some algorithm to decide which features are important, right? Like while in case of degree, we are all the features are considered. It's just combinations that differ. But in feature selection, we are deciding which part of the data to drop. So I think that's the difference.
See, when you are going to polynomial regression, that time you are increasing your feature. So you have two features. From the two, how many features you want? You want 5 or you want 10. So you are increasing the features. In sequential, what you are doing from the 10, you are coming to 3 or 4, which are the most important. So both are working in reverse direction, right?
One thing, what she's saying that I would also agree that feature that hyperparameter comes under the algorithm. It's just like a knob of your algorithm, hyperparameter term. Okay, yeah, it's just knob of your algorithm, like by which you tune your algorithm. It's like a knob of your algorithm. And here, since here we are removing that features, in particular number of features we're selecting here by seeing that correlation, or one more term is like a VIF, variance inflation factor. So have we covered that VIF?
I don't think so.
Okay. So that is also a term like when we train our model, after training our model, we just check the VIF value every time, variance inflation factor. So if it is greater than 5, then we remove that for like we just saw all the VIF value for all our features. Okay, for whatever features like which that is maximum, we remove that one. Okay, and we do like every time one at a time. something like that we do. And by doing this also, like we remove that correlation part. Okay, so that is also there. So there are many techniques by using that we remove features. So here we didn't train, we didn't use any algorithm. So I think this term, by using this term, I'm also trying to
So, I mean, we can also put it in a different way. I mean, what everybody is saying, the argument is correct. So, I mean, it is up to us to choose what type of algorithm we use in order to select the features, right? So, because there are different approaches possible. So in that sense, it's like a hyperparameter tuning. So because you feed in certain number and then it will give you X number of features, like whether it's a polynomial or linear or whatever it is. But in the end, that the technique we are telling, right? So in that sense, the end number of features that we want to keep is based on the algorithm we are choosing. So in that sense, you can say that, okay, the parameter, the feature selection is actually a parameterized technique. I mean, choosing the parameters is not a hyperparameter. The hyperparameter actually aids us in choosing the number of features. So something like that.
I think like what I understand is with parameter, it reads certain characteristics of the data to give us the output. So it learns something like a correlation, or in the case of feature selection, it learns something about the data and then helps us make the selection. Whereas in case of degree, it just returns a combination of the features. There's no special technique, or there is nothing that it's learning or utilizing from the data. It's just giving us some combinations of the features. So I think that's the main difference between why the first one is a parameter and the second is a hyperparameter.
True. So it's basically a technique which enables us to choose the feature. So that way it's a hyperparameter.
This point is valid.
I also remember in the live session I had asked to Ashish sir also. So according to him also, hyperparameters are the parameters in any situation. If we are giving parameters to the model or to the function, so we are just giving so we are defining the parameters, and those parameters are just hyperparameters in a very basic sense.
Yeah, so again, I think more or less we come to at the initial point only, like, yeah, as you told, hyperparameter is something input we are giving to the model. Okay, and here also, like, we are giving the input, like what all features to select. So by using this logic, we are at all other portion we are able to we will be correct, but here I think we are not correct. Like here some different things people are saying related to that, like number of features which we select. Okay, let's discuss something else, or we want to discuss this more. Hello.
Can I talk? Okay, like if there are no questions, like I can ask. Can you explain like what is the difference between cross validate and grid search CV?
I would say just stop, because yeah, we can discuss it later, because it's 1 hour and we haven't discussed, like, let me complete this part. Okay, this question part, because this is like this session is mainly for this part only, no? So this once we'll cover this part, then we'll go through all those parts. Okay, so what are the two hyperparameter search approach? Okay, so yeah, just tell about the answers.
Search and randomized search. Grid search CV and randomized search CV.
Yeah, so it is
Grid
just
search and randomized.
Yeah, so it is just about that they haven't written, like they have written different names. Just in the options they have confused like that only, and nothing else is there. And this one we did not, like, which of the following expressions is correct about the hyperparameters. Hyperparameter is parameter whose value is used to control the learning process. Okay, and hyperparameter that are directly learned within estimators. Yeah, that is wrong. It's not directly learned. Parameters that are not directly learned with estimators. So are you guys with me?
Yes.
Yeah. So this one also you guys told is correct. And which of the following API is used to find the names and current value for all parameters for a given estimator? So which one will be correct? State.
Get params.
Correct. Okay, so again in the fourth question, which of the following option is correct about the grid search CV? Which one do you think it is correct?
The first one is correct. It is
So the third one, I think in the collab it was get param. That S wasn't there, is it?
Sorry?
The third question.
Third question. Okay. Yeah.
Which is the correct option? The fourth one or the first one?
This one. Fourth one.
Okay. Fourth one, it is params, no? We use that.
Yeah, okay. It gives params, yeah.
Okay,
yeah.
okay.
Yeah, whenever you get this kind of document, just you have used that in the collab, just question marks and just put this one. Okay, you will get the answer.
Okay.
Okay. So it will really help you in that proctored exam, because you can, since what I'm saying, are you getting or?
Yes. Asking to check the documentation.
Yeah, exactly. So that will help you. Okay, so again, this one is some parameter settings may result in a failure to fit one or more folds of the data. Which keyword is used to avoid the same failure? This directly comes from the scalar library.
Error score equal to 0.
Yeah. So I'm just trying to quickly cover these things so that we can discuss more later. Okay. So yeah, in this question, like consider the following code in its output. Like for what we are doing, like we are fetching California housing data, and we printed the covariant target length of covariant target, that is 20,640, and number of features, that is 8. So what will be the dimension of the feature matrix? So obviously, whatever is the number of rows, that will be there.
Yeah, second option.
Yeah, second option. Okay. Okay, so what will be the output of the following code? From scalar.dataset, import fetch California housing, and yeah, we kept as frame equal to true. So what it will return? California housing dot feature names. What it returns?
A list of feature names.
Yeah, exactly. It's a list of feature names. Okay. So which of the following features has long tail distribution? So that this directly we can refer from that collab which sir has discussed. Okay, in the video, why Madhouse well has a spike at the end of its distribution? So I think answer was this, but it was whether it's discussed in the collab only or something.
Yes, it was truncated.
Okay. So how many missing values are there in the California housing data set?
0.
Yeah, 0. So obviously is dot any by using that you can check is dot any and is dot. Yeah, so yeah, that is done. So let's go to the, it is 4.4 now only, no? Yeah. So you just okay, just let me log in it. So by the time you can discuss something other. So more or less, I'll try in this in the next SWI session, like we will go by step, like how we will do, like how we first check all the assumption, and based on that we'll proceed and we will train our model. Okay, and first like we will also try to look like what are the decisions we can take from that graphs, like the EDA part. That so like. Yeah, is it visible?
Yes.
Okay. So which module of sklearn contains the lasso API?
Linear model.
Linear model. sklearn dot linear model. Okay. So which of the following will return the California housing dataset as a tuple of features and X labels? So yeah, once we keep XY, return XY equals true, then we get that. Okay.
Yeah.
Yeah. So which what will be the what will the following code implement? What we did is first we transform our this poly to with degree 2, and then we applied a ridge regression by keeping alpha equals 0.5. So I think second option it is saying it will transfer the features to degree 2 and then will perform the regression rate of 0.5. Yeah, that's correct. Okay. So this chart represents the mean absolute error. Okay. So against degree of polynomial features for regression task on California housing dataset, which is the optimal value of degree. So we are able to see that test error increases from
2.
here. Yeah. Yeah, 2. That's correct. Yeah. Because after this, like we are seeing that, yeah, test error is increasing and training is decreasing. So yeah, 2 is correct. Okay. So again, we will discuss this program question. This part, no? So obviously in the first question, it is saying, write the function compute explained variance. Okay. Okay. So compute explained variance, y predict, y true, y predict by keeping these two arguments as input, and for calculating the explained variance score. For a linear regression data set here, y true is the true level and y predict is the predict level. The function should return the explained variance score EVS. Consider y true equals 7494, and yeah, these are the data. For these levels, what is the output of the function? This what will be the out of this function? Okay. So in the sklearn already we have this library. So we directly imported this one, explained variance score, and we put and we return that. Okay. So yeah, that is what if you put here, we'll get this one answer. So anyone has any doubt in this one?
None.
Okay, so can someone tell what is the formula for explained variance score?
What is the?
Formula for explained variance score?
It is just calculating the variance actually between these two.
Explained variance score. Are you saying the formula for this one? What is the like? Okay, just I'll give you it as a task, like just set that formula and just try implementing this code using that normal without using this library. Okay, it is just like like it is like 1 minus variance of y2 minus y predict upon variance of y2. Okay, so that is the formula for this one. And this question, they write a function compute score where the input will be x and y trend. So this thing to compute the score of SGD regression for the predicting the occupancy price of California dataset. Write your code based on the following points. Like first, this whatever it is saying that first they split the dataset with the 70:30 ratio. So that is what we did here by importing that part. And yeah, we here only like yeah they splitted their data. And after they what is saying that import standard scalar for scaling extend and extend to extra norm and extra norm. Okay, so yeah, that is what it is doing here. They have used this part, they scaled their data, and then in the third part it is saying yeah, import as SGD regression edge model with hyperparameter loss as squared error, penalty as L1 and alpha as 0.01, and data set equals 1. So by keeping all these things, they train their model and they return their score. And the model, what is they have used to get the score? What is the error they have used? Oh, the squared error. Okay, okay. Yeah. So based on that, you can do that, no? Hello?
Yes, sir. In this question,
Yes.
actually, I thought of using a pipeline, but it
Yeah.
didn't give me this. It gave me some other error. I didn't understand what is the meaning of score here.
Core. Okay, I would say that you can post on the Discord because then only we can also see that thoroughly. Okay.
I thought I could compute the error and all other thing, but the question says compute the score. Now, what score means? I mean, I don't know what is
Negative of
score.
loss.
Yeah, negative log loss. Here, one thing like you have the total squad is asking, no? Hello.
No, sir. In this question, it is asking the score, right? So, what is expected as output?
I think I also see here what they have used particularly. They have used in this question. That is what I was seeing. Okay, so squad error they are using as a loss function, so that you can return as a score. Okay, so that will. Okay, so yeah, few questions which I had from my side, like because since I just go through that lecture part, that videos, and I thought like whatever are the things covered, and so based on that, I thought I'll ask few things. The first was that assumptions, and second was that like you have just till the different evaluation matrices which you use till now in this yeah, in this linear regression. And one common question, entry question, I would say that part, like what are the just name some different hyperparameters in linear regression, ordinary linear regression. Okay.
Yeah, number of epochs, learning rate.
Both the things are not in ordinary list, ordinary list square regression, like OLS. There is no hyperparameter in OLS, normal regression. That is in regression, no, that learning rate and all. So all these things, yeah, you can say, yeah, in that SD regression there is hyperparameters and all the others, but yeah, in ordinary list regression, OLS there is no hyperparameter. Okay.
No, just a minute. Like ordinary regression means like because whenever you will be doing this update weights, right? You need that learning rate.
I think normal equation method.
Yeah.
Oh, normal equation.
Yeah. So that usually ask many times people ask that part. Okay, and the again then regression that lambda and all, yeah, that alpha comes. So okay, and the next question I was asking that what are the different evaluation matrices you have studied till now?
Like negative mean evaluation matrix, like mean square error, then root mean square, then mean absolute error.
Yeah. Some more just
yeah, some log error, actually log something, forgot.
Yeah, and
Log likelihood error.
yeah,
R2 is also an
yeah, R2, yeah, R square. We read that. R square is there. Adjusted R square is also there. Have you read? Have you read about that adjusted R square?
Yes. Adjusted R square is also.
Yeah. So when to use which one? Have you thought? Have you given a thought about this part? Like you have so many tools to evaluate your model. Which one will you use, and when?
Actually, wherever there is a distance measure, like whether to give kind of a like a root mean square or negative or mean absolute error, like they will more or less give same thing, because root mean square is nothing but mean square error. Like you are getting a different form of that mean square error only, root. Okay. And if it is a kind of like you are sure that okay, most of the things are like you are getting something in positive range, you can take even mean absolute errors.
When we will take that mean absolute error?
Mean absolute error means, like, say for example, your minus and pluses are not getting cancelled out. Say for example, you have a error -1 0 +1, then it will get cancelled out and you will get mean absolute error 0, right? If this is not the case, like
See. First thing, I think you are confused. How will get that -1 in mean absolute error?
No, sorry. Mean absolute error. That means all positive.
Yeah. So that is not a case. Just think about this. Like because we have now we have saved about 45 minutes to discuss all these things only. Okay. So I'll try to give some inputs which is not covered in the lecture, something like that. Okay. So yeah, just discuss that part. So
I think I just wanted to add on the R square. As your model becomes, as the error reduces, you will probably want to prefer using R square because it gives you a better idea about like how what can be a better fit. Is that the right interpretation?
No, no, but we'll discuss that. We'll
Okay.
discuss about that also in details. First, we'll start with mean absolute error. Okay. So what that formula, we all know that it's the formula is 1 minus n mod of sigma y minus y hat. Okay, something like that. Sorry for my bad writing. Okay. So what do you think? Like, what is the issue here you will face? And when to use? Yeah, since this is a simple model. Okay, simple evaluation matrices, because it's just like it is not taking that much help, that much longer calculation. It is like normally just suppose this is your y hat line. Okay, and some point, something like that. So you just calculate, that is simple. Okay, this residual, that is simple. So what is the difference? I would say, means what you are able to observe, something like that, and what is some important part which is it contains, like I am able to clear it?
Not differentiable, this loss.
Yeah, that is one point. Okay, so yeah, we can keep this one, like whether it will be, it will help us or it's a problem. It's non-differentiable. Okay, yeah, that's true. Some other?
And this value will be like, oh,
sorry.
Right.
Go ahead.
This value will be high actually, because this is the similar thing like we use in lasso, right? And we saw that error is high.
You are saying this value will be high. Yeah, as compared to what? In the mean square error.
Root mean square.
Yeah.
Because mean square error will be like squared, right? Root mean square.
Yeah, root mean square error, that I agree. Yeah, here the value will be high. Root mean square from root mean square, it will be high. But normally just we are comparing here also, like for mean, if you compare from mean square error, what do you think? Since the value will be more higher here, no? Mean square error.
Yeah, mean square error, even the unit will be different, right? Square.
Yeah,
That's
yeah.
what I told root means. Like then it will be comparable. MAE and root mean square, you can compare those two.
Yeah, that's why the root mean square error come. But before that, mean square error come, no? Yeah, that is true. That's one advantage. Yeah, in here.
Doesn't it depend on the data? I mean, mean square error is high if there are outliers, right? So let's say, what if the errors are like 0.2, 0.3? If you square it, it will become lesser.
Exactly, that is also one point. Yeah, that is like that only I want to explore, like I want to get idea from you people only. Okay, so that is my approach right now. So here, as you told, like it will, I'll just convert it in the some better term. It gives more penalty. More spelling is wrong. Yeah, more penalty to outliers. Okay, that is what you guys are saying, no? Yeah, that is
For mean square error.
Yeah,
mean square error, right? Yes.
Yeah, obviously from that is the advantage from mean absolute error. Yeah, this is, we are losing here, and in mean square error we have advantage here, like it is giving more penalty to outliers. So by using, if you train our model, if we check our model from mean absolute error, then it is more robust to outliers. One term I think we are able to see here. Here outlier is problem also, and yeah, it will help to remove the outliers, because obviously when outlier is more important, to removing outlier is more important, then we will use mean square error, and by using this we will remove penalty, this outlier term. Is it okay? And one more thing, yeah, as Rajiv told that it's non-differentiable. Okay, so what is the how we can utilize this part? Like here it is differentiable, no? Hello.
Yeah, root means mean square error, right? You are saying differentiable.
Yeah, it is differentiable.
Hmm.
So this is also gives it a benefit because it is a convex shape and it is differentiable. So we can optimize this loss, no, by using formulas and all. Are you with me?
Yes, sir.
Yeah. So that is a major benefit which we feel in, which we get in that mini square order. And as you told that in root mini square terms come to just uh, keep it in by we can say the range, to reduce the range, and yeah, to bring it in the back to this normal unit. Okay, for that we use that root part. Okay, so as I told you,
Which one you are telling robust to outlier? Is it the mean square error or the mean absolute error?
mean absolute error is robust to outliers. Are you confused about that or something like that? It is robust to outliers since it won't value outlier that much, as much it values RMSE mean square values. So when you want to remove that mean outlier part, no, you have to use it. You will use mean square error because since if there will be some outliers, no, it will cost. It will give more penalty to that term. So obviously your error will increase with a large amount. Something like that. Are you guys?
But how do you remove that? You cannot remove that, right?
Oh, it just gives an indication that there is an outlier.
Indication.
Yeah.
Yes.
Yeah, removing the, see, to remove that, yeah, see how what is the use of these matrices? Do you, I think you are just missing that point. So basically what we do is like we train many subset models. Okay, just think at here also, like just cross validation part. Okay, we trained 4 models uh, by using a different data set or some, yeah, just think like just you applied lasso something, anything you did something, change some iteration in your yeah, some tuning in your model, and you created 4 models. Okay, now you have the questions like which among these 4, which model we will keep as your final model. You will have that question, no, like which model is your better, that is your question.
Yeah. In that case, see, the approach that Sir has taken is he has taken all the same errors, right? Now, keeping the error same, negative scoring is negative means mean absolute error. Okay, and with that, whatever is giving you the lowest error, and the variance of that error is like low.
See,
So
first thing is what I will say, like just don't stick to that. Sir is teaching that part. Okay, so I'm just trying to say you that when you will choose which evaluation matrix, that is the part here which I'm covering here. Okay, so what I'm saying is like when you have more outliers. Okay, okay,
mhm.
yeah, you have more outliers, and you trained your model, something like that. You just trained your model. You get this X model. Okay, X1 model. Okay, and you got some error, something like 2000. Okay, and so what you think, like since and you have one more models, just think this model is giving you 4000 errors. Okay, so this difference is there. So what you think is like since this is a large difference, no, and you are getting a large amount of error. Okay, so you will try to fix you saw, just check your model, like you plotted graph, and yeah, just you remove that outliers. Okay, like 3-4 outliers were there, you remove that, and again you train your model by removing that.
Okay, so let me ask
Now,
you like a
yeah,
different question. Okay, say for example, you trained the model with MAE and you trained the model with RMSE. Sorry, mean square error. Okay.
yeah,
Now mean square error you got 4000 and your MAE got 2000.
no, I'm never comparing these two things. Okay.
Right. We cannot.
Yeah, we cannot. That is
Correct.
yeah. So what I'm saying is that when you are saying that your outlier is a problem, mean a bigger problem, removing outlier is your target. Hmm. Actually, by using data only, I think I can able to tell this thing. So
See, there are 2 points, 1 and 100.
yeah,
They are
one.
far apart, and like 100 is the outlier. Assume that part only.
Yeah. Okay.
So your mean absolute error will also give you like a kind of a like a high value of error, and your predicted value, say for example, is 4, right?
Yeah. Okay.
Assume. Okay, so your mean absolute thing is like one is 96, another is 3, right? 99 is your mean absolute error.
99 is our mean absolute error. Okay. Yeah.
I said 2 data points. One is 1, another is 100, and your wipe rate is 3, 4.
What is? What is that?
Can you write down like 2
Yeah.
data points, 1 and 100, and your mean and predicted value is
Data point.
4. Okay.
Value is 4. Okay.
Yes, in this situation, if you calculate the mean absolute error, it gives 96 plus 3, 99, right?
Mean
99
absolute.
divided by 2. I remove that 1 by n because that is there in both the cases. Okay.
Yeah.
It is 99. Now,
Okay.
when you calculate the MSE, you will get 96 square plus 3 square.
Right.
Yeah, 96 square plus 3 square. Yes, that
So
will the value. Both are high.
yeah, both are high. But see, what I'm saying, yeah, both are high, but it is much higher, no? 96 square. Just think about that. That will be in something fort, yeah, near to the 10,000, no?
Okay.
Yeah. So obviously that is it is representing in your error will vary a lot. What I am saying here is it depends completely on the data set, like which matrix you will use. First point I want to make clear. Okay, so based on your data set, you will select which evaluation matrix you will use. First thing is that, and second thing is what I was saying, like when outlier is not in a big issue, okay, then you will use this one, this mean absolute error, and when outlier is a big issue, you have to remove that. In that case, RMC you will use. So how I'm saying is here, because see here, suppose let's say 100, yeah, 100 data point is there, and you got mean absolute error here as yeah 1000. Okay, and in case of 100 here also again 100 data point is there, mean square error you got as, just take it also as 1000 only. Okay, although it will be higher. Okay, so just we add 1 point. Okay, just think, I added 1 point, which here whose residual is something like just 6, take it as a 100. Okay, so that you can see. So now it will, now new mean square error will be somewhere around 1100. Are you getting? But in case of here, in this case, if a new error term is giving a residual 100, but the
10 to the power 4.
Yeah, 10 to the power 4 and plus 10 to the power 4. So you are able to recognize, yeah, some outlier is there, because outlier is increasing your error a lot. So you trend like that only, no? You just try to minimize this loss function, no?
So, that is okay. Like that part I understood. My point is, like when we do the pre-processing, these errors like we use when we do the GD or when we train the model, right?
Exactly.
Correct. But before even training the model,
yeah,
we do that like pre-processing, right? There only we need to remove those stuff. Like in general, that way it happens, right?
Yeah.
You remove the outliers from there itself.
Yes.
Yes,
Exactly.
now you have a, like, say for example, after you did that, you are coming to a data set like which is standardized. That means mean 0 and variance 1. Now you have that kind of a data. Now you are using MAE and MAC, like which one will be better?
Yeah, so yeah, that is what I saying. See, normally you do like that only. Or in the questions, if you are talk about just question and answer, yeah, whatever you're saying, that is the approach. Okay, but in the practical problems which you will do in future, something like that, you don't have any idea. Like you got some data set, and you have to think like how to create some model, and you have to give that model. So what will be your like how you will approach it? No one is there to ask you like you use this evaluation matrix or you use that evaluation matrix. So you will create so many models. Okay, you will create different models. Okay, and based on that you have to select one model. Okay, so in that case you will need this evaluation matrix. Okay, so how you will create these different models, that is what I'm saying. See, this time first time you just kept those outliers. Okay, sometime you just remove outliers, sometime you kept just as you told about now that variance, like you will remove that all the data like which have higher variance more than 0.2, something like that. You did that one model, you trained based on that, something like that. You train different, yeah, by iterating you create different models. And if you are you know that your model has a great effect on outliers. Suppose in case of like the, if a bank is there, okay, and in bank what term is like the, it is one feature is there, that is like his I would say, yeah, his bank deposit, it is a feature term. And if someone like on an average, suppose just like see in everyone's account 10,000 is there. Okay, like yeah, someone has some people has lesser amount, some people has higher amount, but one people likes some kind of Mukesh Ambani, you have lakhs of rupees. Okay, so would you like to remove that or something like since in outliers what we think that like it's unimportant to us, but in those cases do you think that it will be unimportant, it will be not important? I'm confusing you guys or something like that, just tell me that, so then I'll just sort all the things and I'll just tell about that yeah, final conclusion what
No, sir. I think it will be important in this case.
yeah, so that is what I'm saying. So in this case you won't try to remove that outliers. Okay, so based on these things only like we decide the different evaluation matrices. Okay, but since you don't have to use the MAE, RMC, we use the RMC very thoroughly, like in many cases. But still, yeah, based on all those cases, you select your models. So MAE will not show you that much error to your that much increase, error will not that much large after removing the outliers and by keeping the outliers. So that's why we say that it's robust to outliers. It won't treat your outliers. Okay.
So in the case of outliers, is it possible that we may want to retain outliers of certain features but not of other features? Or we need to maintain that entire data set?
It depends. It depends. It depends on us.
Okay, but that's something that's done. Like it's
Yeah.
also okay.
Yeah. So that is, but see, in particularly in linear regression, there is a problem. No, in linear regression, the problem is that our basic assumption is that like our data should follow the this one, this term. What I said, like normalization.
Normal distribution. Yeah.
Yeah. So
Okay.
that's the issue. Or otherwise, in other models, we do that.
Okay.
Whatever you were saying, yeah. We just play with these things. Like first we remove that this much outliers. A second time we didn't remove that much outliers. Okay, so like in few time back, what I am able to remember, like I was working that data set, some hotel chain data set was there. Okay, so in that data set, like what was there in the case, like which hotel is open for like 365, which hotel is available for 365 days. Some hotel is not available for that much days. Okay, so there were in few cases that was the good thing. I mean, in short term, I can say, yeah, that was not an out, that we can't remove that part. Okay. So based on all those things, yeah, we take that different evaluation metrics. Okay. So let's move to the, yeah.
So, but like one question, like when you are saying some of the outliers you will like preserve, right?
Yeah.
Some of the outliers you would like to preserve. Okay. Now, say for example, we talk about this generalization, right? We talk about like ideally, like your objective is you train a linear regression or some you train a linear regression, and finally your model should generalize well.
Yeah.
Correct. Okay.
Yeah.
Now, if you are training that model with outliers, okay, say for example, like some outliers, you know there is an outlier, and you are keeping that intentionally.
Oh yeah.
Okay, and now you are trying to generalize. Like, will that model at all generalize, or will it not be underfit?
The thing is, like it is a particular, like for particular term, there is outliers. Okay, and to check that there are some, we don't consider that outliers. Means we have the independence. Like we take like something, some value which is close to 100. We'll take that value that as a normal value, and we'll remove like 20% with any. As you seen in the box plot only, no? Like any value
Yes,
point.
like
Yeah. Yeah.
anything within that 1.5 IQR, right, plus minus,
Yeah.
you can think of that as a outlier, right?
Yeah.
Okay, and now,
so yeah, that is the case. In some cases you do like that. Okay, but who told you to use every time, like to remove outlier this using this function? No one has told you. No, like when you will just model in your real world data set, it is like that I'm talking. You have the data set and you have to build a model and you have to give it to some companies or some people. Okay, so based on that you have to select, you have to see that whether this outlier is affecting your final answer by a large amount or not. And other thing is like that outlier is important or not. Are you with
okay,
me?
so you are saying that feature importance, that feature importance itself, right?
Yeah. In real world data set, you have to know about that data set. It all these things will depend on the data set. Like you have to know, you have knowledge, you should have the knowledge of like, yeah, whether that feature is important in your final conclusion or not. So if I say about the weight, okay, the final weight of person, okay, or one feature is given as a hair length, okay. So do you think that his final weight is dependent on this feature by a lot? Me?
No, again, I'm like, I'm completely confused now.
See, this
See,
is
outliers dependent upon your domain. Okay, it's not that you have in all that outlier. There are some cases you need to keep certain percentage of outlier which is impacting much more on your model.
No, say for example, like if I go back to that same example, like salary of 1,000 rupees and 1 billion rupees, right? Mukesh Ambani salaries. Okay, now my feature is salary, right?
Right.
Yeah.
Now, not so only one person, or say for example, only like 2% of my account holders have that kind of a salary.
Right.
Yeah.
Now, how that like particular value, like 1 billion, is going to help me in any way?
So, yeah, that completely depends on the data set. Like, what is your output variable? Like, what is your dependent
Output variable is predicting the salary.
So in general, maybe the salary might not be good, but say for example, if you're trying to do some analysis on high net worth individuals, HNI, right? So in that case, the salary of Mukesh Ambani and people in that range might be useful. So in the general sense, if you think of salary including all your customers, you can think salary of Mukesh Ambani as an outlier. But if you consider only maybe analysis which involves high net worth individuals, so in that case, Mukesh Ambani's salary is not an outlier. So in that case, that is the useful.
Correct. So that is altogether different, clustering stuff, right? You are saying like, okay, cluster those people like who has a high net worth.
Yes. So in that case, it's in the general sense, I mean, the entire data set of all customers for that bank, it is an outlier, but not in that case.
See, I would say, see, it completely depends, as you told, no, like it completely depends on the data set, like where you want to keep it, where you don't want to keep it. All these things depends on the data set. And once you will see the data, no, based on that, you will be able to recollect. So that's why, since I am also not getting a proper example right now, based on that, I can tell you, I can demonstrate you. So okay, maybe in solid session I will take that 2 examples where outlier removal is important and when outlier removal is not important. Okay, and then I will be able to show you in a much better way. Okay, just keep this point. Yeah, just day after tomorrow the session is there. No, I'll keep that. Okay.
Yes. Okay. Thank you.
Yeah. For now, you just can think it completely depends on the data set, like different evaluation matrices. Like which one? I was just showing that pro and just a thing. Just keep this discussion on this part only, like the pro and cons of different evaluation matrices. So we talked about that mean absolute error. So that muskil, yeah, the difficulty in this case is that it is not able to penalize more to the outliers. Okay, and that is the biggest advantage for with mini square is there, that it penalizes more to the outliers. More the difference will be there, more the penalty will be there. Okay, so if it is predicting 10 9 and like some term is like 1000 and it's this time see here just 10%. No, here if it will be 10% then it will be 900, and this time the difference is 100. So obviously that the residual is 100 and error will be changed by 100 square. So something like that. By that way it penalizes more to the outliers. So that is the advantage of mean square error. And so R square RMSE comes like it's just like analogous to your standard deviation. Okay, just we do that, just like from variance we come to the standard deviation. Why? Just because to just take that unit and all. So that is like that only, like mean square error. Again we come to the RMSE. Okay, so then one more error is that like mean absolute percentage error. Okay, so why this term came, mean absolute percentage error? So because see here, if by seeing that in one model I got error of 1000 and in another model I gave error of 10,000. Okay, we know this model is bad, this model is good, but by what amount, that we are not able to say by using that simple mean absolute error or mean square error. Okay, so in that case percentage will help. Are you with me? Hello?
Yes, sir. Yes, sir.
Yeah. So just to give you the idea, like you will in your mind you can feel that this much is the difference, something like that. But here you are not able to see because the range is like 1 to infinity, and sometimes the 10 change of the error, like the difference of 10 difference error in loss value, that is a big thing. And sometimes the 1000 difference is also not a big thing, something like that. So in that case, so that mean absolute percentage error will come in this thing, in this situation it will come in the picture. Okay, so like that only we can create a mean absolute percentage error and mean percentage error is also. So then again the term will come like a mean percentage error. So mean percentage error, so here we won't use that absolute. So the problem with this will be the same thing as Rajiv told earlier, like there will be some positive value, there will be some negative value, both will be cancelled out. So it can, there can be a case like where it can say that zero error is there, but in the reality there are a large number of positive errors and large number of negative errors. So both got cancelled out. So that is the problem in the mean percentage error. Okay. So are you guys getting something like?
Yes, sir.
Yeah.
Yes, yes.
Yeah. And then next term our the next term comes here. Which one? Oh, one more. If we discuss mean absolute is there and mean percentage. Then let's talk about the R square. I thought. So what do you understand by R square? Like RSS is there, TSS is there. So how it plots? See, what we do here is like a total sum square error. We what here R square works on what principle is that we just assume a baseline model. We just assume like by without saying that X value. Okay, I just created like I told like whatever you question will you ask, I'll tell the same answer, like y equals to, no, I'll predict y equal to 5. Whatever the value of x you will give, I'll tell that, yeah, output is 5. Okay, it is something like that matrix. Every time, whatever input you will give, input, yeah, different x features, it will give output as 5. Just take it like that. Okay, this is your baseline model. This is what we say, our baseline model. Okay, okay, and so what you are doing, you created some models. Okay, by using linear regression, you created your model, your RSS model is there. Okay, and you kept this here. So now you will get different value. And now if you give same features, you will get different models, no, a different value, output value, sometimes 5, 4, 6, 8, something like that. Okay, are you guys with me?
Yes, sir.
Yes, sir.
Yeah, so that is your model. This is the baseline model. So what you are doing here is R square is saying, yeah, how good is your model when we compare with you the base model. So that is what it is saying. And somewhere there were questions on the discourse, like what would be the range of R square. So what will be the range of R square? Yeah,
Minus infinity to 1, right?
Minus infinity to 1.
minus infinity to 1. Okay, so what does this mean? Like if we have negative error, negative error, what does it mean? So as I told you, like the R square says about that your model, how good is your model if we compare with the base model. Okay, that simple model, like there is a people who is talking about always giving a random tukka, like always is talking, that is also not a random tukka. He's always saying that, yeah, 5, 5, 5, something like that. Okay, so and you created this model. Okay, so that is what R square is saying. How good is your model if we compare it with the base model? Okay.
So TSS will be the variance of the baseline model, right?
Yeah.
Yeah. So
yeah,
if that variance is very small and
just take this question only, like see in this question only, this is your TSS. Okay, this is your TSS, or maybe TSS can some other can be also there, because in this one you want to get that it less than 0. So yeah, just think it like I am saying, just take it theory wise. Okay, there you have some base model, you have RSS. Okay, so I am saying if it is the value of this R square is between 0 to 1. Okay, so as it is increasing towards the 1. Okay, then what it is saying that your model is how good your model is if I compare it with the base model.
Right.
Yeah. Okay, so obviously if it will be 0, then it is like your model is something like that base model only, like how accurate that base model is, the same accuracy of your model. Okay, the performance of your model and base model is same. Okay, so when it will be negative, it says that your model performs worse than this base model also. Okay, so in general it should not perform, but yeah, if it is negative, then it is saying like your model is so bad that you are a person who is predicting every time a tukka, like every time a fixed quantity, and your model is so bad that you are predicting still he is able to perform better than your model. Okay, something like that. Are you guys got my point?
Yes, understood.
Yeah.
So it simply means that yeah, your model is worse than this one also, like this baseline model also. So that was this part. Okay, so R square. Yeah.
The total sum squared error, that will be the difference between the predicted values as per the baseline model and the actual values, right? And sum of square of those.
Yeah.
Okay.
Exactly. So since here your baseline model is predicting like it's a y equal to constant. So every time you are differentiating, say y1 predicted, minus this value, like this 5, y2 predicted minus this 5 value. Okay, sorry, yeah, here it will be y. So predicting this, you predicted 5 every time, no? I mean,
Yeah.
y1 minus 5, y2 minus 5, something like that. Okay.
Yeah.
And this, in case of RSS, it will be y1 minus y1 bar, something like that. Okay.
Okay.
Yeah, like that.
So if I want to increase the accuracy, then I can improve the baseline model itself, right? Which reduces my tolerance to my error. Is that the right way to look at it?
Yeah, that is also an issue with R square. Like in R square, we have fixed that, like, yeah, our baseline model is this y equal to constant. Okay.
Yeah.
So, but this is also issue, like in R square, you can't say like if large R square value is there, then that model is better, something like that. You can't say if you compare different models. That is also an issue here. So that's why the adjusted R square came. In that case, what is the difference here? What is the issue here is R square. It depends also on the, like how many number of features we are providing, and how many number of number of features we are providing. Based on that also, like R square changes. Okay, obviously when you put more number of features, R square will increase. Can I show you, or you guys are getting this?
No, so I mean, I didn't get it.
Yeah. So in the case here, like when you I'll just write R square exactly. If there is some tool type, I should delete that. No, I have. Okay, just for now, just here I'll do. Okay, so what I'm saying, the formula adjusted R square is one minus R square upon n minus one upon n minus k minus one. Okay, this is the formula for your adjusted R square. So yeah, so what is there, like this n is your number of data point.
Okay.
Number of data point. This k is number of variables. Okay, so what is happening here? No? As you increase the number of variables, no, that R square will change. Okay, R square, just take it as a point, or you can just try doing experiment with any data set. Okay, so when you will increase the number of features, no, okay, so this R square value will increase. Okay.
Okay.
But to adjust that only, like so obviously it won't will be like a great method to compare two models. If in case as I told you that in the percentage error, by seeing that you can compare, you can get intuition, like yeah, how far, like how good or how bad both models are, two models are.
Yeah.
By seeing the value, yeah, the difference is 10 and 20 or 10 and 90. So based on that, so that was the difference in R square. If you increase the number of features, then obviously in any cases that R square value will increase. Okay, so to just cover that, we introduce this term n minus 1 by n minus k minus 1. So it just generalizes that part. It covers that part. And now, yeah, by using adjusted R square, yes, if the value is like a 0 to 0.5, then if you are whatever you are intuition you are getting, no, like just like a probability, like yeah, it the chances is increasing, yeah, the model's accuracy is getting good or bad, something like that. Okay, so it's 12:57. Okay, so the last question I would ask, and we use that negative what was the term? I think negative absolute error was there, no? Hello?
In which?
Yeah, negative absolute mean value.
Yeah, negative mean absolute error. Okay. So why we are using negative mean absolute error? Yeah, this is the last question for this session, or maybe you guys can ask anything. Okay. Why they are using a negative mean absolute value? Any idea? Anything, just think anything, whatever you comes in your mind, just say. Like we use that, no, negative mean square. Like, yeah, negative mean absolute error. Why we use that? Because
But
then,
in this case, I think negative mean absolute error is used to maximize something in a way.
somewhat whatever you are saying, that is right, in the right direction. Yeah, just think. Just I want more clear answer. Something like that.
I don't distinctly remember what we are supposed to maximize, but we are supposed to maximize something. That's why negative mean absolute error.
Yeah, see, the job of our error is to do that only, no? Like it does like that. What is the case? Like if here it is just related to okay. If anyone want to try, then just try. Otherwise, I'll explain it. And is anyone will say anything, or I should proceed? So what happened is, any estimator with higher score is rank higher by scalar. Okay, what scalar thinks is if any value is bigger, no, that is better. Something like that, scalar thinks.
Yes,
Okay.
yes.
Yeah. So to deal with this part, like in the library, we use that negative sign. Okay. So what will happen here? Like, see, but it is since it is a loss. If that is 50, and in one case we got 40, what scalar thinks, no, that 50 is better. Okay, because since it is higher, so obviously 50 is better. 50 is better.
Okay, okay.
Yeah. So what we did is we simply provided minus sign. Now which term is greater? This one is greater, no? Minus 40 is greater, bigger.
Yes, sir.
So yeah. So it will just return this part. Like, yeah, it will rank higher to this minus 40. So by using this concept, yeah. So that's why we use that my negative sign. And in the second term, when we are just returning that loss value, we just multiply that with negative sign, so that we get finally that loss value as positive.
Okay, okay.
Yeah. So that was all from my side. Yeah, if you guys want to ask anything or something like that, then we can discuss that.
So explain variance is same as R square?
No, I'm not sure actually.
Okay.
But I don't think that would be same. But I haven't seen, honestly.
Okay, okay. I think the details, like they're similar in terms of what they mean. That's why I was not sure of the formula. I couldn't find the explain variance formula.
Yeah, that I'm okay. I'll just share it with you. Okay. That explained variance formula. Okay, I'll just write it again for that also. I will say. I have to share my screen. So you want that explain variance formula, no?
Yeah, yeah.
So that is something like, yeah, 1 minus variance of y true. Oh, yeah, that. Yeah, that is the formula for your yeah, explain variance.
Okay, Okay.
Okay. Yeah.
Okay. So doesn't look like they're exactly the same, but
Yeah.
concepts are similar.
Yeah. Concepts are similar. Yeah. That's why I told you, like, I haven't cross-checked this thing. So
Okay. Okay.
yeah. So I hope I was able to add some value to you people, or I'm not sure.
Yes. No. Yes. It was a good session.
Good session.
Yeah. So yeah, anything else? And yeah, I'll try to just make a solid session also good, because I'll try to cover all the parts, like how you will think in, yeah, in the structural manner, I would say. Yeah, like that. Or if you guys want to give some feedbacks, then you can give on the, okay, that's not an issue. No, it's okay. Because yeah, and anything else, anything more you want to cover, or just, yeah, whatever you felt about this session, like what we should add, something new we should do, or some suggestions, it is welcome. Yeah, you can mention that in the chat, or maybe in the discourse, wherever you feel comfortable. Or
I think we should continue like whatever today's session was good, because that's mostly generally what I try to search for personally, the rationale behind doing different things. So I think that way it was good, and we should continue that.
okay. And any other suggestions which you want me to do in the live session, next live session, like solve session?
Yes, sir. If you can cover those assumptions part, and also if you could also guide us. So in our main goal is to improve the score of any regression model for this matter. So
Sorry,
there are the...
you are not audible properly.
Hello, am I audible now?
Yeah. Please continue.
Yeah. So what I was saying is that if you could, categorically mention those assumptions once again, before we, start a regression problem. So if you could show us in more details what additional checks are needed other than that what sir has already covered. And secondly, if you could also, guide us what are the tips and tricks how to improve the scoring of a model. Sir has given us some techniques already, but could also probably, from your experience, tell more tricks how to improve our square. So when we get a real life problem, we can try out all those tricks that we have in our arsenal.
Yeah, okay, I'll try to do that. And one more thing, the thing is still there are many better model than the SQL, but many better model than linear regression. But main part of the main advantage of linear regression is there, no, like you are able to visualize the what is happening in the model. Okay, which feature is important. You when you want to know about the importance of your features, no, in those cases, this linear regression model is very helpful. So I still in the industry also, like people practice that part, like they train their model on the linear regression part. So to see the feature importance of the features to do these things. Okay, and nowadays since there are like deep learning has come and different other algorithms are there, so those models perform better. But still, yeah, linear regression has its own advantage. And slowly, the thing is, what I'm able to feel, like in the very few, like if someone doesn't have any background of this machine learning and coding part, so people are what I see on the discourse also, like people are lagging in terms of these things. What do you say? Yeah, like they are saying, yeah, they are lagging in terms of concepts and all. So the thing is, like main issue here is like not something like, yeah, people are not the coding is not shared, something like that. I personally feel that, yeah, in the very less duration, like a lot of things are covered. So I think that's the main issue, what I feel. Or anything else, what you guys think?
Yes, sir, I agree with you on this.
So even at the end of this program, like, do you plan to give that collab?
That one collab, that part I'm not sure. Yeah, I need to cross check with these people. Like these things are decided by the teams, and the word intention and these things they are no, like see that see that pipeline model is there. Okay, just now I have to make some models. Okay, I'll train some models. I'll directly use that pipeline. Okay, I won't see that nitty-gritty things on that part. Okay, when you would have proctored exams, no, in that time you will face difficulty. if you will directly copy that code part, no?
I agree, Jimmy sir, with what you are saying, but the problem, as you said, that as too much of material has been, kind of put into this 12 weeks. So, and on top of that, I mean, we are getting difficulty in managing the time to write the collab. I mean, I'm absolutely on with you with your teaching style that, okay, I mean, we should write our own code, definitely, but the amount of effort that we have to give is kind of exponentially increasing because we have to write everything. So that is my feedback as a student.
That I also agree, because writing code is important, and the syllabus which is getting covered in, like, see, just 3 weeks back in the just December, people does not some person is there that who doesn't have any knowledge about that machine learning, and just after like 3 weeks, he is talking about this building some algorithm, some machine learning algorithm, and machine learning models and all. So that's a very big transition. So that is what. And in the upcoming week also, like so many things are going to get covered in this 12 in this subject. So I expect this kind of review.
So the question as a beginner is then, like over the weeks, as we get a little more familiar with the codes and the coding, this thing for structure for machine learning, is it expected that we'll be a little more comfortable, or there's more complex aspect of coding part? I'm not talking about the concept part, but is it just going to get more complex, like more from a preparation point of view?
From my point of view, the coding won't be that difficult. Okay, coding, just you are saying that just simple things are there, like there is some as you know, you got to know about the terms, and like linear regression library is there, and you have to use those things. Okay, so that's not an issue. But the terms and concepts are so many concepts are going to be covered in this subject, because I also feel like in the 12 week this much concept is too big thing. So you have obviously, and other thing is like they can't cover mix some different subjects like MLP 1, MLP 2. So obviously you have to work hard. That is what I will say.
Sure. I mean, I think that's expected, right? That's fine. But I think at least this is just the beginning. So one of the places where I felt a little stuck was the conceptual part of it. Like machine learning foundations was very much in depth, right? So, but obviously MLT and MLP can't be so much in depth about the concepts, but little more intuition on the concepts will help, because I know it's a balance to be maintained between coding and the concepts, but it would help to explain the concept in a little more detail.
Mostly these things we will obviously you can expect in the next term.
Okay.
Because,
So, like, is there a live session planned with Professor Anand?
Professor
Anand?
Yeah, we can ask him to join the session. Something like that.
Yeah, at least like if he can join for a couple of minutes, like as like first time he told like he will be joining the session for first 10 minutes.
Yeah, he is actually not well. So, and a lot of pressure he also has. So many works are there. So but still he was also interested in joining the session. So
see, actually, like I asked one question regarding that cross-validate and grid search CV, right? So in today's session we couldn't discuss that, and like those kind of things, like keeping like at the end, like it will be very difficult, even like submitting the like your submissions.
Okay. So let me just ask him to just. Sorry, just.
No, it's okay. Like we'll discuss that in Friday, because Friday, like I'll have to ask that question once again.
That what? No, what you said? Just tell me.
Cross-validate and grid search CV. Like if you can explain, like what is the difference between all these things? Like because there are like cross-val score, then cross-validate. Like these things also does like a parameter search, and again grid search CV also does a parameter search. So what is the difference actually, and when to use what?
I would just go through all these things through the code only, because I think the code will be give you the better visualization. what I felt in the what I just I kept the one suggestion from for myself that yeah, I should be prepared with some code part, because that will help me to visualize more better. Because just
Yeah, in that case, like for Friday, if you can at least like spend some time like explaining those differences, because at least I have that query. Or like you can take a like things like what are the key areas, like people can post their key areas, and like those things you can cover.
okay. So actually, the thing is like I was more involved in that MLT content creation. So just I also don't have much idea like what are the things covered in the MLP part till now. So that's why I thought yeah, like yeah, this assumption would have covered. But in the week 4, I lecture, I just go through that part, and I saw yeah, it is not covered. So I thought I'll talk, I'll ask, and if you guys it is covered, then it will be a question, or if it is not covered, then I'll discuss it.
No, Rajesh sir, regarding that question of yours, difference between grid search and cross validation, is that what you were asking?
Yes.
Sir, cross validation is doesn't give the parameters back. Cross validation is just there are two ways. You can either do train test split that is going to give 80% and 20%, or you can do cross validation. So at the end of it, you're just training the model whichever way you want to. That is just a you can think of it as a partitioning of the data set in a way.
No. If you see that there is a API cross_validate, okay?
Yes, sir. In grid search, right? So in grid search, what if you mention that, right? It will inherently do cross validation, and it will also do the hyperparameter tuning. So what it will do is it will divide the data set. If you are given it as CV is equal to 5, it will divide it in 5 blocks, and it will do cross validation on those 5 blocks with all the parameter tuning that you are given, and then it shall return the result. But if you do a normal k-fold cross validation, it is not going to do any hyperparameter tuning.
No, I'm not telling k-fold or shuffle split. I'm not telling that. I am telling cross validate, or like there is another thing called cross_val_score, right? There you can send a parameter grid. Okay, so that is, and from there also you can get the parameters, and it will tell you like, okay, which one is better. Like if you see the week 4, I think like 4.5, right? 4.5 collab, right? So there it is used, like sometimes it was used cross validate, that means cross_validate, and sometimes it is used that grid search CV. And I have tried, like if you give one parameter grid, and then you can get the exactly same result.
Okay.
Exactly same result, and you will see like say for example, you want to find which degree is giving you good thing, right? Cross validate, you will get 2.
Right.
And here also, like grid search CV, you will also get 2. Okay, so the point is, like if you remember that when Sir told regarding that like hyperparameter tuning, he told there are 3 ways. Like one is grid search CV, another is randomized search, and other is like those specialized rich CV, lasso CV, all those things, right?
Correct.
He never mentioned that cross_validate, but in the code, like we use cross_validate as well. So I need to understand like what are the differences. It might be so happen that in cross_validate you cannot send multiple parameter grids. Say for example, like one on alpha, another is on degree. Okay. Probably you cannot send. I'm not sure. So that was the reason I asked that question.
Okay. So no, according to as far as I can recollect, I'm not used cross validation for just hyperparameter tuning of only one